So welcome back, and we are already discussing about network optimization models. In our last session, we discussed the use of gravity location method, where we decide coordinates of various supply and demand locations, and we want to locate a warehouse. So we basically focused that we will locate a warehouse from where the overall transportation cost is minimum, and using the concept of graphical method, where we have calculation of distances on a graphical plane, and to minimize the total cost on the basis of that. And in that we also saw simultaneously the use of Excel, for particularly Excel solver, that how to use Excel solver for such type of decision making with that data, where one manufacturer of automobile company products wanted to discuss that where should I locate my warehouse, and we had some data and we solved that. Now moving further, we want to have some interesting issue related to allocation of the facilities. In last class we were discussing about three important issues. One was role, one was size, and one was location. So we discussed already in detail about role and locations in our last session. Now today we will discuss about the size, that what should be the capacity allocation of my facility. And our gravity location method, the method which we discussed in the last session, that was basically dealing with the locational problems. Now today in this session we will discuss about the size of the facilities, the size of our capacity or the manufacturing facility. So that is what we are going to discuss. Now the allocation of capacity to a particular facility, the key costs are, there is a fixed cost of the facility. So whether you use that facility for 2 products or 200 products, there is to be a fixed cost of the facility, that is there. Then the transportation cost, you are using that facility to transport some product from one end to another end, so that transportation cost will be there. The production cost, obviously this is a variable type of cost, as many number of products you will produce, that much production cost you will incur. Then inventory cost and the coordination cost, you need to coordinate with your different other facilities in the network. So depending upon your location and the size of the facility, this coordination cost will also come. Now the questions which are there in front of you, that you have 4-5 locations in your radar and you need to decide which plants to establish. You want to establish A, B, C, D, E, these 5 locations are there, and out of these 5 locations you can make 10 units here, 20 here, 5 units here. You feel this plant is not suitable, this location is not suitable, so you will not decide to make here, and capacity of 10 units for plant E. So this is what we want to configure the network. We need to decide which plant to establish, and then what should be the size of each of these plants. So both these issues we will like to answer in case of this network optimization models. So for this purpose you have this type of demand allocation model. Now in demand allocation model you see that you have various facilities. You will like to see which market to be served from which facility. Like these are the production facilities and these are the consuming areas, and this is a warehouse. So you need to see that from 1 to 1, this is 1, this is 2, 3. So you are serving your area number 3 from the second facility and maybe from the warehouse also. So the decision of this type, that how your different facilities will provide products to the consumer end, the market, that is very important. And which supply sources are used by a plant? If this is a plant, for a moment please consider that this is a plant. Now for this plant, what type of vendor distribution system 1, 2, 3 are serving this plant? So one issue is with respect to market, another is with respect to plant, that which distribution of vendor will supply to which plant and which plant will supply to which market. So this is the configuration of your entire supply chain network. Now for that purpose, you are simply consider this is site I and this is customer J. So quantities which are shipped from one source, I is source and J is destination. So Xij represents the quantities shipped from ith source to jth destination. So we want to minimize the total cost. So Cij represents the cost of moving, cost of transportation from ith location to jth destination, and Xij is the number of units moved from ith location to jth destination. So Cij into Xij, this product is the total cost of logistics involved in moving X number of units from ith source to jth destination, and we want to minimize this. And we consider that there are n number of sources and m number of destinations. So therefore I varies from 1 to m and j varies from 1 to m, because m destinations and n sources are there. This objective function is subjected to certain constraints. The constraints are that demand of all the destinations are completely met. So if I have 1, 2, 3 destinations, so destination 1 requires 10 products, destination 2 requires 5 products, destination 3 requires 15 products. So my total demand is 15 plus 5 plus 10 means 30. So this is DJ, capital DJ represents that 30. So total demand is fulfilled, and that total demand is fulfilled from various units which are coming from ith sources. So Xij's giving to from I to n to different j's. So that is one important condition, that the demand of each destination is fulfilled. If first requires 10, so I am able to fulfill the demand of 10 from all ith sources. If second requires 5, so I am able to fulfill the demand of second destination from all the sources. If third requires 15, so I should be able to fulfill the demand of all 15 from different sources. It is quite possible once you develop this model and solve this model, that if I have these are the sources, these are the destinations. So if I have x11 is equals to 0, x21 equals to 5 and x31 equals to 5. So this makes the demand of my destination number 1. Which is 10. So it is quite possible that some of the sources may not supply to some of the destinations, but for the sake of modeling we write in such a fashion that all ith sources will supply to a particular destination and the demand of the destination is completely met. Now there is a question to think about. The question to think about is that why we are fulfilling the complete demand, why we are fulfilling the complete demand. In some cases it is also possible that you have less than equal to sign here, that you cannot supply. The meaning of that is you cannot supply more than the demand of a particular destination. In that case, if a destination requires 10 units here, if first destination requires 10 units, so you can supply 8 units, 9 units, 7 units, but you cannot supply more than 10 units. That will signify here what we are assuming in this model, that we are fulfilling the 100% demand. We will develop our model, we will configure our model in such a fashion that we will be able to fulfill the 100% demand of a particular destination. So in some cases you can take less than equal to dj, but in no case you can take that this is left hand side is greater than equal to right hand side. No market will accept that you supply more than its demand. So therefore this greater than equal to sign in favor of left hand side is never possible. Now coming to the second constraint, the second constraint is about the supply. A particular supply from a particular source, cannot supply what it is producing. It cannot supply more than its capacity. So if you are supplying from ith source and ith source has a capacity of k units, so the total supply from ith source to various destinations, to all the destinations from j equals to 1 to m, should be less than total availability at ith destination, ith source. So the second constraint represents this, and obviously this xij represents the constraint of non-negativity, that the value of xij cannot be negative. So these are the important conditions of the model that you are fulfilling. You have the mathematical representation there, but the meaning of the mathematical representation is that we want to fulfill the 100% demand of each destination, and a source cannot supply more than its capacity. So these two things are written in the form of this type of mathematical expression. Source cannot supply more than its capacity. We want to fulfill the 100% demand of each destination. Now moving further, you see, now we have another situation. We have multiple sourcing locations. Like this particular case, where you have A, B, C, D, E, and in this case you have multiple sourcing locations with different type of capacities. So here you see, we want to minimize. In that case, in the last model, we did not consider the fixed cost. We discussed about the fixed facility cost. So in that model, we are only allocating the demand, and we are only bothered about the transportation cost, but we didn't consider the fixed facility cost in this particular model. Now here in this particular case, we are also considering the fixed cost of facility, and that is what we are seeing here. This step in this case is the same what we discussed in the previous slide, that is the cost of transportation. But out of these locations A, B, C, D, E, at some location I want to have a plant and at some location I do not want to have a plant. So where I want to have a plant, that is represented by yi. I introduce a new decision variable here, yi, and yi signifies whether I want to have a plant at a particular location or not. So the yi takes the binary variable. Yi is represented as a binary variable in our model. It can take only two values, 1 or 0. The value of 1 signifies that there is a plant at a particular location, and 0 means we are not interested in opening the plant at a particular location. And fi is the fixed cost of opening the plant. So the fixed cost will only apply when yi will be 1, and if yi is 0, so this factor will become 0. So if you are not interested in opening a plant at a particular location, so there will not be any fixed cost associated at that location. So in this model you are having more comprehensivity, where you are considering the transportation cost as well as the fixed cost. And as usual, this is the first constraint, that you are interested in fulfilling the 100% demand of a destination. The second constraint, it determines that you are interested, you can only supply what you are producing at a particular facility, at a particular plant. Now the important thing is that in the earlier case it was only Ki. In the earlier case it was only Ki is this Xij from j equals to 1 to n should be less than Ki. But nowadays you have introduced Yi also, because it is not necessary that there is a plant or not. So to introduce that factor, that this Ki will be there only when the plant is there. If plant is not there, you cannot supply anything from that location. So to take care of that issue, because if at D there is no plant, so you cannot supply anything from this location D. So therefore to take care of this aspect, we have multiplied the right hand side of this constraint. If you see the earlier slide, it is only Ki, but now in this case it is Ki into Yi, so that this Ki will only be operative if a plant is there, otherwise it will not. And then you have the last factor, that is sigma Yi is less than equals to K, means the values of Yi can only take place 0 and 1. So you can have the value of Yi, only the sum of that should be less than 1. Therefore you cannot think of if two different types of, the meaning is that at a particular location, here if I want to conceive two types of plant, one is of a smaller capacity, another is of some large capacity. So I will only open one particular plant at this location. So to take care of this aspect, this third constraint is being added, that Yi should be less than Ki. And after this we can think of developing a model. So let us go for some kind of data. So this is a data available to us, which we will use for developing the spreadsheet model. Now here in this data, I again request you all that you can open your Excel spreadsheet and you can copy this data from this table, and you can use the same columns and rows, so that whatever formula we develop, you can exactly follow same formula. Now what we have certain supply sources. These are available in USA, Brazil, Denmark, UAE, Vietnam and there are certain demand points. These are same USA, Brazil, Denmark, UAE and Vietnam. Now, the demand of these destinations, for USA the demand is 12 units, for Brazil it is 6, for Denmark it is 14, for UAE it is 16 and for Vietnam it is 7. Now, at each of these locations, USA to Vietnam, you can have two types of plants, low capacity plant and high capacity plant. Low capacity plant means of 10 units and high capacity plant means of 20 units. The fixed cost for opening a low capacity plant at different locations from USA to Vietnam, that is available from G4 to G8. The fixed cost of opening a high capacity plant from USA to Vietnam is given in I4 to I8. It is different at different location. Now, coming to this data from B4 to F8, this data B4 to F8, this data is the cost of transportation and production. If I am producing 1000 units, so cost of production and supplying 1000 units from USA to USA is 50 rupees. Then from Brazil to USA it is 70 rupees. From Denmark to USA it is 120 rupees. This includes cost of production as well as transportation. And from UAE to USA it is 90, Vietnam to USA it is 150. So, this data is available from all combinations in B4 to F8. So, this is the data. At USA to Vietnam, you can open either a low capacity plant or a high capacity plant, and fixed cost is given. Demand of various destinations are available to us. Now, we have to decide whether to open plant at USA, Brazil, Denmark, UAE, Vietnam. So, which are those locations where we like to open the plant, and what will be the size of those plants, whether these are the low capacity plants or high capacity plant. And idea is same, we want to minimize the overall cost of production, transportation and the facility cost. So, now let us see, I hope you have copied this data in your Excel sheets. So, this data, once the same data which we copy in the Excel sheet, now we make a decision variable table in the same spreadsheet. Just below the original data, we develop a decision variable table. So, you can also use for making this decision variable in the same format. Here, actually what we want to determine? We want to determine two things. One, where to open the plant. Second, what will be the size of that plant. And third, when we are configuring our network, that from which supply source to which destination, how many quantities, how many units will be served. So, these are three important questions we will like to answer. So, these three are our decision variables. Whatever we want to determine, that becomes our decision variable. So, this is how you will make your table. So, these are almost the similar kind of table as you are seeing the upper part of this spreadsheet. USA, Brazil, Denmark, UAE, Vietnam, these are the supply sources, these are the destinations. And to initiate the problem, to initiate the solution, because I do not know where I will open, from where how much I will ship to a particular destination, all these are marked as zeros just to initiate the solution process. Now, we will develop formulas. Now, formula, the objective is to minimize the overall cost of fixed as well as variable. So, now the formula for objective function will be, because this is the representing the whether a plant will be there or not, and these are representing the number of units to be shipped from a location to a destination. So one cost will come that whatever you are supplying from USA to USA, whatever you are supplying from USA to Brazil, that units you will multiply with the cost of transportation. So this cell B4 needs to be multiplied by B14. That is, and similarly for all these cells, they need to be multiplied respectively in this portion of the table. So this is one type of cost which is coming because of production and transportation. The second cost will come because of the developing a facility, because of the opening of a facility. So this is, if you open a facility here, means low cost. So in those places one will come, and if you open a high capacity in this column, in those places one will come. So these values of this column need to be multiplied, because this is for the low capacity, these to be multiplied respectively by values of this G column, and the values of this column here from H14 to H18 need to be multiplied by the values of I4 to I8 respectively. So that is what, and then you need to take the sum of all these products. So we have written that from B14 to F18 we are multiplying by B4 to F8. So that is one sum product, that is for production and transportation cost. Then G14 to G18 will be multiplied by G4 to G8, that is cost of opening, fixed cost of opening a low capacity plant, and H14 to H18 will be multiplied by I4 to I8, that is the fixed cost of opening a high capacity plant. So that is the overall cost, and this is my objective function which I want to minimize. So this is the place where I will put the formula for my objective function in cell B31. This is the place where I will put my formula for B31. Now, as we discussed that this will come with some constraints also, what we discussed in the beginning. Now for that, developing the constraints, in this spreadsheet you see we have given some rows and columns for writing the constraints also. The constraints will be with respect to demand and with respect to supply. So in case of demand, we will see the unmet demands are there, and unmet demand means in these places you have 12, 16, 14, 16, 7. So all these places you will have the unmet demand, that in the beginning of this calculation no demand is fulfilled, and finally we will see that all these unmet demand should be fulfilled, and initially the capacity of these places are considered to be 0, 0, 0. So we see that where to develop the capacity so that this unmet demand is fulfilled. Now in this session we are stopping at this point, and in our next session we will see that how to build that formula into this spreadsheet so that we can invoke the solver and we can get the result, and we will also see how to analyze those results. So thank you very much.